Okay, hey guys, we are starting off the second PowerPoint, I guess, or notes section of chapter 11 in our introduction to hydrocarbons. So these notes are going to be for 3 lecture periods long. So it's kind of a long PowerPoint, but it's got 3 lectures worth of material or 3 days worth of material for it. And you've got your reading chapters and practice problems here for you to do. So this section, section 5, is where we're going to start talking about unsaturated hydrocarbons. So we have saturated hydrocarbons and unsaturated hydrocarbons. So saturated means that it's saturated in its number of hydrogens. They have the maximum number of hydrogens attached to each carbon. So everywhere that you could have a hydrogen, there's a hydrogen. There's all single bonds, as many hydrogens as possible. These can be are called alkanes or cycloalkanes, and they have only carbon-carbon single bonds. So some examples of these are butane and cyclopentane, drawn below. You see how they have all single carbon-carbon bonds. However, in unsaturated hydrocarbons, so what this section is now talking about, they are lacking in hydrogen atoms attached to the carbon chain. So they are unsaturated in hydrogens. There's 2 different versions of these. You can have alkenes, which have carbon-carbon double bonds, which I'll typically just draw like that. And then you have alkynes. And alkynes have carbon, whoa, how did I do that? Carbon-carbon triple bonds. So alkene, like that one, alkyne, like this one. So it's important also to look at the geometry of these atoms. So an alkene, each carbon atom is going to have 120-degree bond angles, and it's flat. The shape is then trigonal planar. So we have one central atom with 3 groups around it. And then over here with the alkynes, we have a 180-degree angle because now we have a linear complex or a linear carbon. We have 2 things around that carbon, and they want to be as far apart from each other as possible. So now we have that linear shape. So alkenes and alkynes, that's what this whole section is about. Okay, so alkenes and alkynes, we need to learn how to name these as well. And how you do this is you change the suffix to show what the saturation is. So for an alkene, instead of ending with ANE, you're going to end with ENE. And then for alkynes, instead of ending with ENE or ANE, you end with YNE. So alkene ends, the name of the complex ends in ENE, therefore the name of the compound ends with ENE. Alkynes, the same, YNE ending. So we saw with propane, for example, that's our alkane, ANE. When we have the same number of carbons, 1, 2, 3, but now we're at 1, 2, 3. I'm going to go backwards. You'll see why in the next slide. But 1, 2, 3, we have a molecule of prop as our number 3, prop, and then ENE at the end to show that it has an alkene. Same thing with our alkyne. We have 1, 2, 3 carbons. So we have propyne. Okay, so let's do another example real quick. We have ethane with our first molecule here. Then we have ethene when we have it as a double bond. And then ethyne as the triple bond. The reason I have some names in parentheses here is you'll see at the top we have a little star that says names in parentheses are common names. So ethene you can also see as ethylene. That is the common name for that molecule. However, ethene is how we will talk about it. And then ethine is also called acetylene. So that's used in acetylene torches. Ethene is the most produced organic compound in the world. So there's over 109 million tons produced a year. And it's a natural plant hormone for ripening. So having ethylene around your like bananas or something, so they produce ethylene and then a little bit, and then that ethylene surrounding it will then ripen the fruits even more. So let's do a little bit more complex naming. So in order to name our alkenes and alkynes, the first thing that we do is start with the name of the longest chain that contains the double bond or triple bond. So the longest chain in the molecule, but it has to include that alkene or alkyne. Then number 2 is to number the carbon chain starting from the end closest to the double bond or triple bond. And then number 3 is give a name and location for each substituent alphabetically as a prefix. So that stays the same as what we had done before. So then it has a little star here, label the carbon number that the double or triple bond starts at before the chain length. So I'll give you some examples of that in just a moment. So let's go to this first one here. We have name the longest chain that contains the double bond or triple bond. So we only have one chain in this. We don't have a substituent. So we're going to number it 1, 2, 3, 4. So in number 2, it says number the carbon chain starting from the end closest to the double or triple bond. So let's double check. We've done that. Our double bond starts at carbon number 1. We don't have any substituents, so we're not going to worry about that. So our name is then going to be bute because we have 4 carbons. Then we have ENE, describing that there's an alkene. And then as it says in this little star, right up here, oh, ENE, there we go. We need to say where the alkene starts. So I'm going to put a 1 in front of butene to say what that means is that the ene is at the 1 position. The alkene is at the 1 position. Let's try another one. Now we have another 4 carbon chain, and we have a substituent on this one. But let's go ahead and we found no matter which way you really number this carbon chain, you're going to get 4. And it doesn't really matter which way you go for this one, but let's go ahead and just give ourselves a number. So we have 1, 2, 3, 4. So if we have this numbering, let's check number 2. It has a carbon chain starting from the end closest to the double or triple bond. So either way that we number these, forward or backwards, we're going to have the double bond starting at number 2, which is great. So I'm going to keep the numbering here because then this also keeps my substituent. Let's circle that guy. It keeps my substituent at the lowest number possible, which is number 2. Okay, so again, we have bute. So let's come up with our base name, and then we can add our substituent. So we have bute, and then we have ene. So 4, bute meaning 4, ene meaning there's an alkene. And then we're going to put a 2 in front of butene to say that the ene is at number 2. And then now we're going to add our substituent as a prefix. So I'm actually going to move this whole thing up a little bit just so I have enough room. Okay, so my substituent is a methyl group at the 2 position. So I'm going to write 2-methyl. That is nice and cozy right there, isn't it? Well, 2-methyl 2-butene. Great, so let's try the next one. Okay, we have a carbon chain. We don't have any substituents on this one, so we don't need to worry about that. So let's number it, starting on the side closer to the double or triple bond. So triple bond in this case. 1, 2, 3, 4, 5. We have to be super careful when numbering alkynes because since it is linear, it's super easy to forget these carbons on the end. So there's 4 carbons straight in a line whenever you have an alkyne. Okay, so we have 5, so our base is going to be pent. Then we're going to show that we have an alkyne, pentyne. And then all we have to do left is to say where that yne started, that triple bond started. So it starts at the 2. The first number that has that double bond or triple bond, that's where it starts. So we're saying that the yne starts at number 2. So that's our name right here, 2-pentyne. Okay, let's do another example. This one is a cycloalkene. So we need to think about our numbering for our cycloalkenes or cycloalkenes is how we learned it, and apply that to our alkenes. So in this case, we don't have any substituents, so we don't really need to number anything. So we're going to keep our prefix of cyclo, put our number of carbons. So in this case, we have 4, so cyclobute, and then we just change our ending. So it's an ene. Cyclobutene is the name of this molecule. We do not need to say number 1 or number 2 or whatever for the this particular one because there's only one thing. It has to be at the number 1 position by definition. Okay, and our last example here, we have this another cycloalkene ring. So we're going to number our substituents, and we're going to start at the alkene because that is what our numbering says to do. So now we have to prioritize either our alkene or alkyne or our substituents. So we always will start at the alkene or alkyne. So even if there's a big substituent or something, always start at your alkene or alkyne. So in this case, I'm going to put my number 1 here so that I can go my number 2 to finish the alkene. And then my number 3 goes right to that next, the closest substituent. So we have 1, 2, 3, and then 4, 5, 6. Okay, I'm going to circle my substituent just so I remember what it is. And then we'll start with the base. Our base is cyclohex, meaning there's a cyclo, and then there's hex, meaning 6, and then ene. We have to say where that ene starts. So 1 cyclohexene. That gives us our base cycloalkene, and then we add our substituents on. So at the 3 position, we have a methyl. 3-methyl-1-cyclohexene. Okay, so that's where we're going to stop with this video. We're going to pick it up with some practice problems. Go ahead and go forward and do them on your own. Try and name those molecules, and I'll see you in the video.